Hi everyone, so we are going to start today on page 19 of your note packet and look at section 1.4. All of section 1.4 has a huge focus on rates, ratios, and proportions. So some of the things that you want to consider as we go through this section is why is it important to include units when you write a ratio? So that's something that you'll make sure that you include. Can you tell if two ratios are equal? And what does it mean to say that a group is disproportionately represented? So we'll go back to the explore activity later, and it is on another page, so don't worry about that one for right now. And we're going to jump right into our definitions. So these will help you understand all of the different aspects that we're going to be looking at in this section. So a ratio is a comparison of two numbers, and it can be written in three different ways. So it compares two different numbers. For example, if the student to faculty ratio at a college is 40:1, the ratio can be written with a colon, or it can be written as 40/1. Another way that you might also see it is with the words right there. So you can see it with the word two, you can see it with the colon, you can see it as a fraction, and that is really going to be the only ways that you see it. And the one that we're going to see most often is as a fraction. So when quantities being compared in the ratio have different units, we call this a rate. So if we have different units in the numerator and the denominator, it's going to be called a rate. So as an example, the rate 30 miles per gallon is a comparison of two quantities, 30 miles and 1 gallon. It is perhaps easier to see this as a rate when we write it as a fraction, so 30 miles over every 1 gallon, or 30 miles for every 1 gallon. So since the units, miles, and gallons are different, we refer to this ratio as a rate. So it is a rate because we have a different unit for the numerator and the denominator. Okay, for example 1, you are going to ask yourself the question, which are rates? So you're going to ask yourself, which of these below are rates? So we want to have a comparison of two numbers. So we want to compare one number and another number, and we want them to have different units. So when we look at this first one for A, we have 70 miles for every 1 hour. So we have two numbers being compared. This one is miles, this one is hours. So yes, this one works. For B, it says 70 miles every hour. And that really just means, when it says every hour, that just means for 1 hour. So that one would be a rate as well. C says 17 miles in 15 minutes. So we're comparing 17 miles and 15 minutes. Two different numbers with two different units. So that one also. For D, it only says 70 miles. Well, what are we comparing 70 miles to? It doesn't say. So this one will not work because we don't have a comparison to anything. For E, 315 miles after 4.5 hours. So we're comparing this one to this one. So that one works. And for F, 1 mile in 70 hours. So we're comparing mile to hours. So all of them work except for D. So it is common for recipes and mixtures to use the term part instead of a specific unit like cup or tablespoon. A part is any unit of volume, such as a teaspoon, cup, quart or gallon, so it can be any kind of volume that you look at. And the person who creates the mixture can choose the unit based on the amount being mixed. So for instance, if we are mixing paint for a wall, a part could be a quart, so it could be something that large. But if we're mixing paint for a canvas, a part could be a 1 second squirt from a paint tube. So that would be a much smaller measurement. For example 2, a juice drink recipe calls for 3 parts orange juice and 2 parts pineapple juice. So this tells us the ratio that we're looking at. And I'm going to go ahead and write this so that we can see it as a fraction. And I'm going to abbreviate the OJ, or the orange juice, to be OJ. So I'm going to say 3 parts OJ for every 2 parts PJ for pineapple juice. And we're going to see which of the statements below would follow the recipe that we see. So for A, it says for every cup of pineapple juice, you need 1.5 cups of orange juice. So it's saying if we've got 1.5 of OJ, how many will we need of pineapple juice? And so it says that we need 1 of pineapple juice. So if we were to change this to follow the recipe, because right now this one is a decimal, so it's not really ideal right now. So if we were to follow it as a recipe, what we could do is we could think of, all right, well, to get from 1 pineapple juice, I need 2 pineapple juice to follow what the recipe says. So that would be multiplying by 2. Let's see what we get when we do the same to the top. So 1.5 of OJ times 2 would be 3 of OJ. And this one matches the original. So this one works. We're happy about this one. For B, it says for every 2 cups of pineapple juice, you need 6 quarts of orange juice. All right, so let's rewrite this one. Let's keep the order the same as how we originally have our recipe. So I'm going to put the 2 of pineapple juice on the bottom, and I'm going to put 6 of the orange juice on top. We could simplify this. Looking at 6 over 2, both are divisible by 2. So I can divide the top and bottom by 2. So that would be 3 of OJ for every 1 of PJ. Well, now this doesn't match because we have 3 for every 1. So we don't want 3 parts OJ for 1 part pineapple juice. So for this one does not work. For C, it says when juices are mixed together, the mixture is 3/5 of orange juice. So I like to kind of make a drawing of a fraction bar. We've got 5 parts of the recipe is what it's saying by being over 5. And it's saying 3 of the parts are orange juice. So if 3 parts are orange juice, we want to figure out how many parts are pineapple juice. And that would be the 2 that are left. So when we look at it like that, we've got 3 of orange juice for 2 pineapple juice. So this one is a match. Okay, for D, the ratio of pineapple juice to orange juice is 2 to 3. So you have to make sure that you look at the order here. They used pineapple juice for the 2 because that one was stated first. So they have 2 for the pineapple juice, and for the orange juice, they have the number 3. And if we look at our recipe, that's a perfect match. For E, it says if you have 15 ounces of orange juice, you need to add 10 ounces of pineapple juice. So this is 15 of orange juice, and they say 10 of pineapple juice. So 15 and 10, that is a fraction that we can simplify. And 5 goes into both of those. So if we divide 5 on the top and bottom, we get 3 of OJ for every 2 of pineapple juice. So this one, when we compare it back to the original, it's a match. So far the only one that didn't work is B. Okay, let's look at the last one. It says if you use 4 of pineapple juice, you can make 6 cups of the drink. Okay, so this one, just like letter C, is comparing it to the whole mixture. So whenever it compares it to the whole mixture, that's one that I like to draw the picture. So it's saying that there are a total of 6 cups. 4 of the cups are pineapple juice. So that leaves 2 of the cups to be orange juice. You should kind of already be like, this one's a little bit shady because you have more of the pineapple juice than the orange juice, which is not what we want. So when I rewrite this one, it's going to be 4 of the pineapple juice and 2 of the orange juice. If we simplify this one, we could simplify it by dividing by 2 on the top and bottom because both numbers are even. We get 1 part orange juice for every 2 parts pineapple juice. Okay, that definitely doesn't match our original recipe. So for this one, that one does not work, F. So there are many instances in which we need to determine if ratios are equivalent, and this can be done by simplifying the ratios or scaling one to see if it equals the other, which was what we did here with scaling. That's where we multiplied or divided by the same number on the top and bottom. Looking at example 3, it says create a rate that compares the suggested saturated fat grams to total calories for a 2,000 calorie diet. So you want to pay attention to what it is giving you for the units. So this one says saturated fat, and it is asking for us to give it in grams. And then it wants us to compare it to the total calories, and it says for a 2,000 calorie diet. So I'm going to use it to compare to 2,000 calories. All right, so when we look to the right over here, this has our nutritional values for a 2,000 calorie diet, and it also compares it to a 2,500. This one says that we want to compare it with what we see for a 2,000 calorie diet. So you guys are going to be using these numbers. So, and it also says your daily values may be higher or lower depending on your calorie needs. So each row here breaks up the diet into different parts because we eat different kinds of nutrients throughout the day or for our overall diet. So we have fats, we have cholesterol, we have sodium, we have carbohydrates, we have protein. So all of these influence what we should eat, and it's also based on the intake of calories. So you're going to see that the amount of fat versus carbohydrates versus protein will or should end up possibly being proportional to the amount of calories we consume. So this one says the saturated fat for a 2,000 calorie diet. So I'm going to look where we have saturated fat, and I'm going to use the one that is for the 2,000 calorie diet. So that was 20 grams. Okay, It then says to simplify the fraction. So you can even type this in your calculator. So if you want to type in as a fraction in your calculator 20 over 2,000, it should just pop out for you 1 over 100. And so we can rewrite this fraction as 1 gram of saturated fat over 100 calories. So what it's saying is for every 100 calories that you consume, you should have 1 gram, or it technically says less than. So you should have 1 gram of saturated fat or less than that. So for part B, it says to create a rate that compares, it's still saying saturated fat grams to total calories, but now it's saying for a 2,500 calorie diet. So if we look right here, we've got the saturated fat right here, but if we look for a 2,500 calorie diet, it's 25 grams. So for this one, I'm going to write it as 25 grams of saturated fat for every 2,500 calories. And we can go ahead then and simplify this in our calculator as well. So 25 over 2,500, and it will also give us 1 over 100. So we can see that this will simplify to be 1 gram of saturated fat for every 100 calories as well. So for part C, it asks us to compare your answers in the previous two questions. And what do we notice? So if you look at your final answer for part A, it is 1 gram of saturated fat for every 100 calories. If you look at your answer for part B, it's the same exact answer. And one thing to notice is it wasn't the same exact in the beginning, but when it was simplified, it was the same. So we have the same exact rates. And one thing to notice is that it happened after simplifying. For part D, it says to interpret the new simplified rate in words. So, and this is something that we talked about when we looked at really what this meant. So we can say that it is suggested that a diet should have 1 gram or less of saturated fat for every 100 calories. And we can even add regardless of the amount of calories consumed. So, for a conclusion, since the comparison of suggested saturated fat calories to total calories is the same for each diet, we can say that the number of saturated fat grams and the total number of calories are proportional. And this is a big takeaway here. So because when we simplified the rate, they ended up becoming the same, these are proportional, which means that they form the same ratio in each calorie diet. So that brings us to our formal definition of proportional. So when two rates are equal, they form a proportion. And we can also use the wording in proportion or proportional. They just mean the same thing. So as an example, if we have the rate 1 man for every 5 women, it is the same thing as saying 3 men for every 15 women. And that holds true because if we were to simplify the second fraction and divide the top and bottom by 3, this would be 1 man for every 5 women. So notice that a specific ratio is maintained. The number of women is always 5 times the number of men. So you would always have 5 as many on the number for the women as you do for the men. Another perspective is that when the number of men are tripled, so is the number of women. So if we tripled the number of men, we also triple the number of women. Sometimes one ratio can be turned into another by scaling, and that's what we just did there. So to scale a ratio, you're going to multiply or divide by the same non-zero number. And when we scale a ratio, we can say that the two ratios are equivalent. Okay, for number 4, it says, suppose you have been hired for a job that pays $12 per hour. Is it true that you make 20 cents per minute? And is this equivalent to $480 in a week with 5 8-hour shifts? So we can do this in a few different ways, and they guide us through this. In the first method, they said we can write 20 cents per minute as a fraction. So 20 cents for every 1 minute. We can write that as a fraction and then scale it so that we have dollars per hour. So we don't know how many dollars per hour it's going to be, but what we can do is we can think that in 1 hour, that is equal to 60 minutes. So I'm going to change this to be 60 minutes. So if that is 60 minutes, I'm going to ask myself, what do I need to do to the bottom to make it 60? So I would have to take 1 times 60 to make it 60. So I'm going to do the same to the top, because if I do it to the bottom, I got to do it to the top. So I get 1,200 cents for the top. I'm going to go ahead and now rewrite this as dollars per minute. Or sorry, dollars per hour. So we know that 60 minutes is the same as 1 hour. So for this one, I'm not changing the numbers. I'm not scaling it up or down. I'm just changing the units because we know that 60 minutes equals 1 hour. For the top, I can now think of, well, 1,200 cents, I can figure out what that is in dollars because we know that 100 cents equals $1. So if there's $1 for every 100 cents, I can just think, well, divide that by 100, and that will be $12. So 20 cents for every 1 minute is the same as $12 for every 1 hour. The second method of doing this, in a similar way, we can write $480 per week as a ratio and then change 1 week to 40 hours. So let's first do that. So we've got $480 for 1 week. And then we're going to change that to be 1 week as 40 hours. Because they told us at the beginning that you have 5 8-hour shifts. So if you have 5 8-hour shifts, that's the same as 40 hours. So 1 week of work is the same as 40 hours. So didn't ask me to do anything now to the top yet, but then it says we can do this by dividing the numerator and denominator by 40. So if we look at 480 and 40 and we were to simplify this fraction, we could see that both of these have 40 evenly go into it. And 480 divided by 40 is the same as $12, and 40 divided by 40 is 1. So in either scenario, we get $12 for every 1 hour. So as an observation, the scaling process shows us that making $12 per hour is equivalent to making 20 cents per minute. So $12 per hour is the same as 20 cents per minute, or $480 a week when you work 40 hours. You can also check if the two ratios are equivalent by converting them to a decimal. If the decimals are equal, then the ratios are equivalent. So that's like last week when we checked to see if 2/3 was the same as 5/6. You could go ahead and divide those and see if you get the same answer. So that's what it's saying there. So we can say that the quantities are in proportion. If the ratios are not equivalent, then we say that they are disproportionate. So a lot of times our final answer will be they are in proportion or they are disproportionate. All right, looking at example 5, it says that nutrition guidelines suggest that we consume 25 grams of fiber for a 2,000 calorie diet and 30 grams of fiber for a 2,500 calorie diet. Is the suggested amount of fiber proportional to the number of calories? And then the follow-up question is it almost proportional? So this kind of gives us a hint that like maybe they're not going to be perfect. So let's check this. It says the recommended amount is 25 grams of fiber for every 2,000 calories. That's for one diet. And then the other diet says 30 grams of fiber for 2,500 calories. So I'm going to check and see if we get these to be proportional. So I'm going to just simplify the fractions, and I can just enter this in my calculator. So I get 1 gram of fiber for every 80 calories. And for this one, I end up with 3 grams for every 250 calories. Well, this doesn't seem to be really a simple way to see if these are proportional, because all the other ones, when you simplified your fractions, you got the same exact fraction. So we can see that because these did not simplify to be exactly the same ratio, we don't have exactly perfectly proportional rates here. So what I'm going to do is I'm going to change these to be a decimal. So you can just take 1 divided by 80 and change it to a decimal, and we get 0.0125. And if we were to kind of interpret that, that would be 0.0125 grams of fiber per calorie. We're going to go ahead and do the same thing over here. We're just going to take 3 divided by 250, and we get 0.012. And this would be grams of fiber per calorie. Now, something that I want you to not be confused about here is when you look at this one, you might be thinking, well, this has 4 decimal places, so that has to be a lot bigger. But when you are working with decimal places, if you don't have as many in one of the decimals as the other, you should imagine it to have a extra 0 or however many extra zeros you would need at the end. Because with decimals, you can add zeros on the end to compare them. So now when I look at this, this is 125 out of every 10,000, and this is 120 out of every 10,000 if we were thinking of decimal places. So when I look at these now, these are really close. That's really similar. So these ones are almost proportional. I'm going to have a skip number 6, so you do not need to do number 6. Or number 7. And I'm actually going to have a skip number 8 as well. Don't worry about those ones. So, for this question, it says, according to the U.S. Department of Justice, from the year 2003 to the year 2009, there were 2,931 deaths related to police arrests. Of these deaths, 41.7% were white and 31.7% were black. If the U.S. population of approximately 322 million is approximately 63% white and 13% black, are black people disproportionately likely to be killed by police? So it says, are more black, and then it has another follow-up question, are more black people than white people killed by police? Fully explain your reasoning and include the number of white people and black people in the population and in the death count. Okay, so this one is a longer problem that we have here. So the first thing that I want us to do here is I want us to find the numbers for the number of deaths and the number of people overall in the population. So we've got a total of the total deaths by police was 2,931. We know that 41.7% of those were white and 31.7% were black. Now we're going to be looking at using percents with numbers here. You may be thinking that with a problem that with the work that we're about to do, that we haven't really gone into this that much, and it's true. And we're going to be looking at it in the next few sections later. So looking at it with section 5 and other ones as well. So if this seems a little bit shaky for you as far as the math of finding the percent of, don't worry. We're going to review it more in chapter 5, and this will not be a focus on your section 2 to section 4 exam, or quiz. So don't worry too much. All right, so if we want to find the exact number of white deaths by police, we're going to take 41.7% of 2,931. And to do that, you're going to change the percent to a decimal. And we did go through changing it from a percent to a decimal. You can think divide by 100, or you can think to move the decimal 2 places to the left. So I'm going to take 0.417 and multiply it with 2,931. And we get 1,222.227. So that's approximately 1,222 white deaths. Okay, let's go ahead and do the same for the number of black deaths. For that one, we're going to take 0.317 and multiply it with 2,931. And we get 929.127. So that's approximately 929 black deaths. Okay, so we are able to answer one of the questions. We're not able to look at disproportionately or not, but we are able to look at, are more black people than white people killed by police? So when we look at our numbers here, we have more white deaths by police than black deaths. However, the main point of this chapter is looking at proportionality. So we also want to figure out, well, how does this compare to the population? We know from our data here that there are more white people in the United States than there are black people. So are black deaths disproportionate by police compared to white deaths? So I'm going to go ahead and look at our overall population. And I'm just going to use the space below as well. So it says that 63%, we've got a total of 322 million, which is the same as 322 with 6 zeros after it. And for our white population, that is 63%. And for our black population, that is 13%. So to find the number for our population, I'm going to take and change that to a decimal. Whoops, I want to keep the same color so it's less confusing. Times our overall population. And we get sorry about that. Sometimes after I've used the stylus for a while, it gets a little bit wonky because the laptop heats up and stuff. All right, so for our white population in the United States, we have 202,860,000. Okay, we're going to go ahead and do the same for our black population. So as a decimal, 13% is 0.13, and take that times 322 million. And we get, whoops, sorry, that was my dog barking, I apologize. Okay, so we're going to take 0.13 times 322 million, and we get 41,000,000 860,000 Black people. So I'm going to see with the number of deaths versus the number of individuals for our population if they are proportional. So we're going to take and create two different ratios and see if they are in proportion. So on one side, I'm going to do those that are for the white individuals. So I'm going to take 1,222 white deaths for the overall white population. And I'm going to do the same thing for the Black population. So we're going to have 929 Black deaths for 41,860,000 people. So instead of simplifying this, because it's not likely that these are numbers that are really going to simplify that well, I'm just going to have us divide and look and see what we get as the decimals. So for the left, go ahead and just take 1,222. Okay, so we're just dividing. Sorry again. So we get, and it does seem like a lot of zeros. So there are 1, 2, 3, 4, 5 zeros, and then 6024. For the right side, we have only 4 zeros, 0.22193. So we can see that it's way more likely to look at the number of Black deaths compared to the number of white deaths. Okay, so this is like saying it is 0.0022% of the overall population, and this one is 0.006% of the overall population. So you can see it's a lot more. So we can see that these are not proportional, not even close. And it asks us, are more Black people than white people killed by the police? And we can say that there are more Black people killed by the police. In terms, so like when we look at our individual numbers, we have more white deaths, but when we look at our individual proportions as a percent, we have more for the Black deaths. All right, this is not part of the problem, but if you wanted to look at overall, how many more times likely is it? We can take the top number as the number of the decimal that we got for the Black population over the decimal that we get for the white population. And you could divide those to see how many times more likely it happens in the Black population. And if we divide that, we get 3.684. So it's almost 4 times as likely as likely that a Black American will die, and they worded it by police, than a white American. So even though the data says, yes, there are more white deaths, when we look at it in terms of the population percentages, it tells us a completely different picture. And that's the picture that is the truly important one. So just to give us kind of an idea of why ratios and proportions are so telling and important. Okay. The next page I will start on the next video for you guys. So there are some more notes for this, so make sure that you guys pay attention. The next page is also something that's really important, and you'll see similar problems like this on your homework.